Section 3.2.RA-11. The following data for a random sample of banks in two cities represent the ATM fees for using another bank's ATM. Compute the range and sample standard deviation for ATM fees for each city. Which city has the most dispersion based on range, and which city has more dispersion based on the standard deviation? So for city A, we have our 5 data values: 2.50, $1.25, $1, $0, and $2. For city B, we have $1.25, $1, $1.50, $1.25, and $1.50. So for part 1, if we want to find the range for the ATM fees for city A, we need to find the largest value in our data set, which is 250, and then we're going to subtract the lowest number in our data set, which is 0. And so we get $2.50 for the range for city A. For city B, the largest data value is 150, and we're subtracting the largest data value, which is $1. So we get 50 cents for our range. Okay, now what we want to do is we want to be able to find the variance and then the standard deviation. So what we want to do is we know the value of n, and the value of n is the number of data values that we have in our city. So there's 1, 2, 3, 4, 5. So we know that n is going to equal 5. It's also going to equal 5 in this formula. What we want to do is we want to find the sum of the data values squared, and also we need to find the sum of those data values and then square them. So what we want to do is we want to be able to then determine what is the sum. So the first thing we need to do is we need to figure out what is the sum here, meaning we need to find out what this is. So that means we need to add up all of these numbers. Okay, so if we want to add those up, we can take 250 plus 125 plus $1 plus 0 plus 2. So we get 6.75. Okay, and now we need to take each sample data and then square it. So in order to find the sum, we need to take 2.50 and then square it. We need to take 1.25, square that. We need to take 1.00, square that. 0.00, square that. And then 2.00, and then square that. So let's go ahead and do that here. So we have 2.50, squaring that gives us 6.25. We take 1.25, square that, that gives us 1.5625. If we take that 1 and we square it, we know we're going to get what? 1. When we square 0, we're going to get 0. When we square 2, we're going to get 4. So now we need to add these all up to find the sum of that squared. So we get 6.25 plus 1.5625 plus 1 plus 0 plus 4. And that gives us 12.8125. Okay, so let's do the same thing over here for part 2. We're going to add up all these numbers to find out what the sum is. So we're going to take 1.25 plus 1 plus 1.50 plus 1.25 plus 1.5. And that gives us a sum of 6.5. Then we do the same thing. We're going to take 1.25 and then square it. We're going to take 1, square it. 1.50, square it. 1.25, square that, and then 1.50, and then square that. Well, since we already squared 1.25 over here, we already know that that answer is going to give us 1.5625. And we also have it here, 1.5625. We know that when you square 1, you're going to get 1. Okay, and then if we square 1.50, let's go ahead and do that. 1.50, square that, it's going to give us 2.25. So let's go ahead and then add those numbers. So we have 1.5625 plus 1 plus 2.25 plus 1.5625 plus 2.25. And so that gives us 8.625. So we were able to find the sum of this and the sum of this. And now what we're going to do is we're going to plug these numbers into our formula. So to find the variance, we know that the sum of these squared is 12.8125 minus 6.75 squared divided by 5 over 5 minus 1. We plug that into our calculator and we get a variance of 0.925. Similarly over here in part 3, we're going to plug in the sum of the values squared is 8.625 minus the sum here, which is 6.5 squared over n, which is 5, divided by 5 minus 1 gives us 0.04375. Now in step 4, finally, we're going to find the standard deviation. Remember that the sample standard deviation S is obtained by taking the square root of the sample variance. So S is going to equal the square root of 0.925, which is approximately 96 cents. Over here, likewise, the sample standard deviation is the square root of the variance, which is square root of 0.04375, which is approximately 21 cents. Now, to answer our question, remember that dispersion means the degree to which the data are spread out. So to talk about the range, recall that the range for the ATM fees in City A is $2.50, and the range in City B is 50 cents. We're going to use this data to determine which city has the most dispersion based on the range. Likewise, for number 5, the standard deviation for ATM fees is, for City A, is 96 cents, where the standard deviation of City B is 21 cents. And you're going to use that data to determine which city has the most dispersion based on the standard deviation.